Most people don't know that, in fact, natural gas is the world's fastest growing fossil fuel in terms of use. Also, there was a 32% increase in production since 2005. It is also widely available. There are 48 shale basins around the world containing 70 different shale formations. This equates to around 5,760 trillion cubic feet of recoverable gas. This is a vast amount of untapped reserves. Natural gas hasn't always been this widely used, however. It wasn't until the ancient Chinese that we humans utilized natural gas on purpose. These Chinese made pipelines made of bamboo shoots and used the natural gas to light lamps. Natural gas as a light source became popular in England in the late 18th century with the advent of the Industrial Revolution. However, natural gas was eventually eclipsed by Edison's light bulb and other electric lights. After this, natural gas was not used very much, because there was no reliable way to transport it across the country from its site. Newer and better pipeline technology was developed, which helped fuel the rise of the suburban residential zone. Natural gas has an interesting chemistry. It is made up of a number of different compounds, but is comprised primarily of methane, which is made up of 1 carbon atom and 4 hydrogen atoms. Methane, along with the other compounds found in natural gas such as ethane, propane, and butane, are all hydrocarbons, organic, highly combustible molecules that are formed from the remains of plant and animal organic matter. Because of this, natural gas is considered a fossil fuel along with coal and petroleum. More recently, natural gas has 4 main uses: residential, industrial, electricity generation, and some transportation vehicles. In terms of residential use, natural gas is becoming more and more common in the homes. It is primarily used as a fuel for space heating, but it can also be used for cooking and water heating as well. Percentage-wise, about 70% of current homes available on the market include a natural gas heating system. Another growing area of natural gas usage is in electricity generation at power plants. One common method of generating electricity with natural gas is called the combined cycle method. This is where natural gas is first burnt in a gas turbine, where the now heated gas flows through the turbine to cooler areas. The exhaust gas from this combustion cycle is then run through water, producing steam which goes through a second steam turbine. The use of 2 turbines in this cycle has greatly increased the efficiency at which we can produce electricity with this natural gas. Additionally, while it is not very common, some vehicles use natural gas as a form of fuel, such as the catabuses at Penn State University. Compared to other fossil fuels, natural gas tends to be much more efficient. It is much more efficient than heating oil in terms of space heating, and through this combined cycle method of electricity generation, energy efficiency of power plants has increased from a meager 33% to a 68% efficiency level. This increased efficiency means that we are burning less fossil fuel, meaning less emissions in the long run.
Now, let's take a look at how fracking actually works. First, a shaft is drilled several hundred meters into the earth. From there, a horizontal hole is drilled into the gas-bearing layer of rock. Next, the fracking fluid is pumped into the ground using high-performance pumps. On average, the fluid consists of 8 million liters of water, which amounts to about the daily consumption of 65,000 people, plus several thousand tons of sand and about 200,000 liters of chemicals. The mixture penetrates into the rock layer and produces innumerable tiny cracks. The sand prevents the cracks from closing again. The chemicals perform various tasks. Among other things, they compress the water, kill off bacteria, or dissolve minerals. Next, the majority of the fracking fluid is pumped out again. And now the natural gas can be recovered.
Natural gas is a cheap fuel alternative. Natural gas typically ranges from $2 to $3 per 1,000 cubic feet of gas, which is around 50 to 66% cheaper than conventional gas wells. Further advances in technology have the potential to drive down prices even more. In regards to the environment, there are lower emissions of sulfur oxides, nitrogen oxides, and mercury from natural gas than from either coal or oil. Another major advantage of natural gas is that it has the potential to decrease our dependency on foreign oil by replacing gasoline and oil. Fracking is an extremely profitable expenditure, allowing for both the businesses and the individuals to prosper. The impact the drilling has on water is catastrophic. Drill sites require 2.7 to 3.9 million gallons of water per well. This water could have been used to clean, cook, drink, or even hydrate crops. The water used in the fracking process becomes contaminated and must be disposed of properly. Natural gas drilling is also extremely detrimental to the air. Methane is released into the atmosphere during the fracking process. This greenhouse gas is 20% more damaging than carbon dioxide. The United States has had very relaxed regulations on fracking, which has allowed for the industry to rapidly increase. While this has been an economic benefit, it has led to negative environmental ramifications. Recently, the EPA proposed stiffer regulations on the fracking industry. The goal of these new regulations is to decrease the methane emissions by 40 to 45% in the next 10 years. Drilling companies are saying that these restrictions are too harsh, while environmental groups believe that they do not go far enough. The state of New York instituted a ban on fracking in 2015, despite the potential for economic growth. Governor Andrew Cuomo believed that the negative environmental effects were too great a threat. Natural gas has a lot of potential in the immediate future. However, it cannot be a viable energy fuel source for the long term due to its environmental impact. Within several decades, the natural gas will be gone and the environment will be greatly damaged. The negative environmental effects make it dangerous to humans, plant life, and the atmosphere.